So, last week we were looking at the drilling over the existing jacket. Basically, you can see from the picture the cantilever rig is protruding outside the jack-up rig footprint and then comes onto any of the wells. Normally, each well platform we have is a matrix of wells 3 by 3, 2 by 2 or just one row of 3 depending on the the reservoir capacity. At least I have seen maximum of 4 by 4 like 16 wells, 20 wells, some of the biggest reservoirs they may have 20 wells. So, the platforms basically if you look from this edge to this edge will keep on growing depending on what is the capability of jack-up. Normally, when you arrange a well bay, first thing what we need to look at is which particular jack-up rig we are going to plan to drill. Typically, I will make one sketch which I think depends on, for example, this is the edge where jack-up rig is going to come, maybe something like this, and the jack-up rig has the capability to travel in the direction of the length of the jack-up and also can travel in the other direction. Now, if this is your well platform, depending on what is the transverse direction the platform can the drill rig can move, because you are not going to relocate this jack-up rig, you are going to keep the jack-up rig at that same location, we are not moving, only the mobile platform which is on the top of the jack-up is going to move forward, backward, laterally, transverse in both directions. Now, if this is your jacket leg, what will happen is you try to arrange, say for example, 3 by 3 matrix of wells. Now, the distance between each of the well is the biggest question, depends on the diameter of the well and also the other equipments attached to the well. I think I have shown you a picture some time back, an instrument called Christmas tree which is mounted on top of the well, which is basically a pressure and flow control regulation with so many valves and devices. So, if you draw a dotted line what are installed on top of it, you will see that the diameter of the obstruction free space required can be calculated. Typically, this is 2 to 3 meter. Now, imagine I want to have 20 wells, this will give you 15 wells. So, I cannot keep on growing, because by the time I reach this well the distance would have already become 1, 2, 3, 4 into 3 meters, 12 meters, which the jack-up rig cantilever cannot reach. So, I decide to go for example, additional wells on the transverse direction, provided what is the travel mode of the rig that it can travel, because on top of this if I can travel this way I can achieve maximum number of wells. So, before deciding the jacket design you need to decide what jack-up, which are the potential possible jack-ups you can hire, because you do not know, you will never know which, you are not the owner of the jack-up, jack-up is going to be hired by the oil company. Sometimes big oil companies do have their own jack-ups. So, once you know which jack-up you are going to do, then you configure the number of wells and then design the jacket. So, you can see the linkage between design of jacket and the jack-up rig availability and suitability for that location. You may have a jack-up rig, but it may be not suitable for that location because spud can penetration is too much or maybe the design is not sufficient. So, there are so many complexities in arriving at the well configuration, all depends on this so called the movable drill floor, forward and backward movement and the transverse movement. So, this is something that you need to keep in mind whenever you are looking at a jack-up for design of fixed platforms. For drilling purposes, you must look at what is the capability of the drill floor movement longitudinally and transversely. And as I mentioned earlier on the other class, basically the height also matters. For example, if you go to Middle East, Gulf countries, so many offshore platforms are there. As I mentioned, the wave heights are very small because it is a sheltered area, maybe maximum wave height you will get maybe 11 meters, 12 meters. So, the structure height need not be very high because the wave crest elevation is going to be smaller. So, no issues with jack-up, because jack-up can go up to 23 meters, which 23, 24, 25 depending on. Whereas, when you come to some other locations, the wave height itself is 23 meter then there is clear space requirement. So, the structure goes higher and higher, jackups cannot get elevated so high because the availability of leg length. The same jackup can work elsewhere, but cannot work in other locations. So, you have to look at all these parameters, just not only every jackup can go anywhere and then drill, which is not the realistic idea. So, you need to look at all the parameters related to that particular location, starting from soil, sea state conditions, type of drilling, well dimensions, all those things needs to be evaluated for each and every location when you are planning to do a jackup drilling activity. Typically, the cantilevers for most of the jackups, the vertical face of the jackup from here to the distance between the jacket and jackup, typically about 9 meters, 10 meters, depending on the design, because this really matters. The closer that you go, the interaction between the jacket and the jackup is going to be more, means the disturbed soil will be degrading the capacity of the jacket. So, we want to keep it more, but if you keep it more, we have a bigger issues with the actual purpose for which the jackup is designed, because the drilling becomes very limited. If you go too close, your jacket becomes a problem. You may also get into problem with the jackup, because there will be movement of the jacket itself. So, the interaction becomes quite substantial. So, we need to find a balance. Typical number is what I have given is about 9 to 10 meter, that is the kind of spacing we are looking at for most of the shallow water jackups. Now, after doing all that, we have seen the animation, we have seen the process by which the jackup is installed in the vicinity of a jacket. Now, when we want to extract, how do we come up? Basically again the reverse process you can think, but it is not exactly reverse process, because you may not be able to pull out very easily, because all the soil have already collapsed into the pit created by the movement of the spud can during the installation. So, what happens is, over a period of time, because if you are drilling for say 3 months, 6 months, mostly not less than 3 months, because every time when you go for, you do not want to go and mobilize a drilling jackup for drilling only one well, you will drill 3 wells, 10 more than 3 or something like that. So, it may take several months. So, during the process, the sea state conditions may change, wind conditions may change, and the debris and the soil which was actually coming out during the installation may actually go back, and also the sedimentation of materials brought from elsewhere because of the subsea current can also get deposited into the hole. So, slowly it will get consolidated, settle down. So, what will happen is, you have to pull this leg against the soil capacity, which we call it the breakout force, to get the soil failure in the vicinity. So, now that capacity could be substantially more than when you were installing, you were not encountering this problem. So, what we need to do is, how do we reduce this breakout force? Either loosen the soil, maybe a process by which you can do a water jetting around the legs to loosen the soil. But potential problem of water jetting could actually damage the jacket, because your jacket is in the vicinity, very close, 10 meter away. So, if the water jetting is not done properly, you may actually collapse the soil in the vicinity of the jacket legs, which make the pile to fail, and which is not very good. So, water jetting is the last resort if the leg is not able to come out, and probably will be taken by the superintendent. But before that, we need to make a design, and the required uplift capacity of the hydraulic and the motor winches required for moving the leg up have to be arrived based on simple soil mechanics. So, the basic idea is, I have just prepared few sketches to show what really can happen, because we have the spud can prepared in a way that it has to go down easily during the installation, because we got a downsized cone with a very sharp edge, which facilitates going down. But at the same time, we also have to have upside cone, so that when it is trying to come out, also can come easily. Imagine if you have a flat surface, what will happen? It is very, very tough, because then you actually going to lift off the whole soil, which will take larger effort in bringing out. So, you just make a slightly reverse tapering and arrange. So, these calculations needs to be made depending on type of soil, because not all the soil is going to flow. If it is a soft clay, probably it will flow downwards when you are trying to move up, but if it is a stiff clay, it may actually get stuck to it. So, depending on the type of soil material. So, the various stages you could easily understand how the failure is going to really happen. Basically, if you look at the stage 1 is very deep below into the mud line, and when it is trying to pull off, a cone of soil becomes part of the lift process. The leg is trying to come out and it carries that much of soil from this picture, and the breakout or so called the failure plane could be potentially the conical frustrum, basically the conical surface around the spud can boundary. And stage 2, as you come closer and closer to the mud line, then what happens is the cone is there, and also the failure is not going to be there because it has to come out. There could be potentially a failure surface elsewhere slightly away from the cone, which is shown in the dotted line you can see here. So, this could be a possible failure plane which you have to break out, so that the whole soil can come out and just come outside the seabed. And basically, as you come closer and closer, variety of things will happen. The soil will try to collapse, because by the time when you have come to this stage, almost the plane has been defined, the failure plane has been defined by the process of movement, and the soil will try to collapse and come to the underside. And if this process happens very fast, there could be potentially a suction pressure at the bottom, basically because of the hydrostatic pressure is say 100 meters, and you are trying to pull off, and that pressure could be acting against. So, these are the things that we need to take into account when you are trying to pull off the leg. Now, of course, if you do not have this soil at the top, movement becomes easier, and if the soil is like disturbed clay, probably easier. But if it is a sandy soil, imagine breaking this failure plane could prove to be potentially difficult. So, we need to see what is the material that is going to be filled after you erect the jack-up. So, leave it for 3 months, 6 months. If there is a lot of sand transport, I think you might be doing in your hydrodynamics course, sediment transport along shore. If it is a coastal area, then a lot of sand material can get transported from one location to other location, can get deposited. Then this is what normally happens. You do not have that kind of prediction. When you try to come and remove, you are unable to remove, because your winch capacity is already predefined. You cannot change at that time. So, that is the problem when you may encounter. So, that is a situation you will resort to water jetting, because you already have the jack-up there, you need to come out of it, and unable to come, then you have the auxiliary measures where you can jet water, loosen the soil, or just bring out little bit of soil from the mud below mud line, and then try to remove. So, this reason why we need to know how the spud can extraction is happening, this is going to affect the neighboring structures, because when you remove like this, for example, you may actually form a crater like this. Most of them we call it jack-up leg mark, basically the mark left by the leg after the removal. So, this will be permanently there. Of course, over a period of time, the soil might collapse slowly from the sides and may become a slightly depression at 3 locations, but over a period of time it will get filled and then may come to the natural state, but still the soil becomes quite loose, and that is what we need to know, because we need to understand what is going to be done to the jacket because of this loosened soil. So, typically the drilling over the jacket, I think we have discussed most of the parameters. Position of wells, height of the deck, I have just mentioned about each of these parameters needs to be considered before arriving at which jack-up is suitable for this particular site. This is a picture I was trying to draw in the blackboard. Basically, the position and the number of wells and the array of wells supposed to be decided by the jack-up dimensions of the movable drill rig. Jacket leg configuration, I think I did explain early when we were talking about jacket configuration for well platform, process platform. Always well platform, one of the face we keep it vertical, just to make sure that the jack-up can come closer. So, if you go back to this picture, maybe this picture, you see here this particular jacket leg is inclined, whereas the front leg to face the jack-up we have made it purposely vertical, otherwise what will happen, this leg will go in this position too close to the jack-up leg penetration location, which will be potentially not good, because soil is already disturbed. So, and also the distance between the jack-up leg and the jacket leg will become too small. So, always the leg, whenever you are designing a jacket for drilling by jack-up, then you need to keep the vertical face one side, but if the jacket is not going to come and drill, you do not need that, then you can make a jacket of symmetric configuration of all the legs are 4 directional inclination, because anyway jack-up is not going to come, because you are having a drilling rig on top of the platform itself. So, basically the jacket leg configuration, we cannot have any protrusion outside the leg. The meaning is, if you have, this is the leg location, we do not want to have any structure projecting outside the vertical face of the jacket itself. So, that is the very important thing that we need to note down, especially below water, because below water only your jack-up legs are going and then penetrating. Cantilever support on the deck, basically how much we can the design of the drill floor is done by the jack-up people. Sometimes what happens, you have a jack-up, the owner has a jack-up, but your well configuration, whatever I have drawn on the board, is such that I have to go a little bit beyond. So, what can be done? Either I modify the jacket design or modify the jack-up design. So, the simplest idea is, we could go and provide additional support to the cantilever rig. Many times we do this, instead of say the drill floor is not possible to extend beyond 10 meter, why not we give a support from the jacket. That means we can go a little bit far, because instead of cantilever it becomes supported condition. So, many times we do this exercise. That means we need to find out what is the load transfer from the jack-up drill floor to the jacket, so that we could consider that amount of loading in the design of the jacket structure. So, this is also sometimes done, because you already have the jack-up, you do not want to modify too much, and you still want to approach say another row of wells, so that you can maximize your production. What are the other aspects that we need to look at when you are installing at a jack-up at particular location is listed down, especially the geotechnical aspects. First of all, we need to look at the hazards, which we are going to see in some scenarios which can happen. Basically the seabed conditions, which is most important, that if the flat seabed condition exists, there is no big problem, because you will be able to install the jack-up very easily. Suppose undulations, whether we should do a leveling before bringing a jack-up, or if that undulation is within the limits of acceptability, then you do not need, because every time when you want to go and do a leveling, it is not an easy exercise, especially underwater removal of debris becomes expensive. So, that is why we need to evaluate that type of situations which may come. Sometime what happen, actually you might do the leveling, but by the time you bring the jack-up, there may be a gap of say 1 month, 2 months, 3 months, something else might have happened, some of material transported from elsewhere, because sea conditions you can't predict. So, there may be a small amount of material deposited, which has occurred between your leveling time and the jack-up coming in, which is unknown condition. You might have thought that it is already leveled perfectly nice, but when you are installing your jack-up, at that time there is a little of. So, those kind of unforeseen scenarios, what happens to the jack-up we need to evaluate. Environmental conditions, for sure, before bringing your jack-up to any site, you must make sure that during the period you do not see a environmental conditions exceeding the design limit. And we will look at possible failure modes. I think few of the pictures will give you an idea how they can potentially get into failure modes. Evaluation of ballast capacity to achieve preload condition, which during the installation process we did evaluate, or we need how much weight to make the leg penetrate x amount of depth, because we need to increase the weight. So, as long as you have the volume of ballast available, then it is possible. Suppose your ballast tanks are so small, you may need higher than the ballast tank capacity, then you cannot do the ballasting. So, mostly we do ballasting using water. For example, if you go for iron ore ballast, then the volume required will be smaller, but who will bring the iron ore to this location? Very difficult. Every time you have to keep one transport barge to transport the iron ore, which is not very good. So, that is why mostly jack-ups do not use heavy ballast material, use only seawater ballasting, and that means the volume required needs to be pre-calculated for a particular site. you may have the jack-up, it may be not suitable for a particular site because that particular location soil is too good and you need a bigger ballasting capacity which your jack-up does not have. You may not be saying you may not be using that jack-up for that site because it is not suitable. So, the evaluation, the ballast capacity evaluation has to be done for site to site. That means depending on the soil capacity, depending on the soil at each location, you will decide whether that particular jack-up is suitable or not suitable, and that will depend on the geometry configuration. Bearing capacity of that particular site for a given jack-up for operating conditions. That means at final drilling time, what could be the capacity required for the spud can. Effect of jack-up leg penetration and its effects on the jacket or other structures in the vicinity, which is very important. So, you could see a substantial amount of work, especially on the geotechnical aspects, which I think most of you will be attending our course on foundations next semester, I think. So, basically these are the aspects we need to relook at every time. And effect of jack-up leg withdrawal, because you saw just now how it is being withdrawn, and what is being done is created a disturbance to the soil in the vicinity, and how much effect we should consider in the original design of jacket, because you are not going to evaluate the jacket after you withdraw the jack-up leg. You need to pre-condition, that means you need to understand what jack-up is going to come here, you have to pre-plan, and for that jack-up what could be the disturbance created by the jack-up leg, and that needs to be taken into account in the design of jacket. So, you can see how much upfront you have to have your thinking pre-planned. It is not that after you install the jacket I will come and evaluate, I will put one more piles. You cannot do installation of pile after the jacket is installed. So, that means for a particular location, if you have planned X, Y, Z type of rigs for drilling, only those things can be used. You can't bring a new rig unless it is very similar in behavior to that previously designated rigs. And then evaluation of jacket stability during storm conditions, basically because of the changes in soil behavior. What are the hazards? Basically one is the easy to understand is the hard material, but of course rock outcrop very rarely experienced, because you may not have even installed a jacket there, because if there is a rocky material at that site throughout the area, you may have planned for a different type of offshore structure, because you may not be able to drive the jacket piles, because rock outcrop will not allow. But sometimes what happens is rock boulders, jacket is in one location, when you are bringing in a larger footprint required for jack-up, you may find one of the leg is encountering a big boulder material, which was not removed because it is little bit away from the jacket, because people might consider why I should remove, it is far away, or there may be a material, scrap material dropped from several barges going around, like pipes or like other waste material simply dropped. Many times people do this, because bringing back is expensive than just throwing there any scrap material. So, that could be potentially problem. Big depression either naturally occurring or previously made leg mark by the previous jack-up comes and going, and sloping seabed, soft layer at the top. So, these are some of the scenarios which might occur, or more than this. So, each time we need to evaluate this. So, what will happen when you have a rocky material or a hard material, when the jack-up is trying to go down, only one leg, the other two legs are trying to go down. So, what will happen? This is not going further penetration, because material is very hard. So, you will see a tilting of the jack-up. Depression, basically again a similar idea, except that it might go faster than the other legs and basically not getting adequate support. So, try to tilt exactly opposite way. Soft material at a particular location, 3 legs are there about 50 meters apart. One scenario I would want to explain how soil profile changes, especially in subsea conditions. The last time we were trying to install a jacket, 4 legs, the footprint of the leg spacing is about 50 meter by 50 meter. So, that means the diagonal distance could be about slightly higher than 50 meter, and one borehole was done at the center. That means the soil investigation revealed that there is a particular profile of soil, and then design the pile and install it. But at site 3 of the piles there was no issues in driving, one of the pile was not going through, means about 15 to 20 meters short, unable to drive within these short distances. So, you could see the variability by assuming a central borehole by drilling a hole and taking a soil sample does not reveal the variations within that 50 meter radius. So, you could see that there could be a local pocket of variable material which could cause this kind of trouble for us. So, if you look at one of the leg 50 meter away, local pocket of soft material, thin layer, which may be not there in other 2 locations. So, one of the location is just punching through, the other location is supported very well. If all 3 of them punching through is no problem, because it is going down uniformly, stability may not be a issue, whereas the one of the leg is trying to tilt, you will see that the jack-up will become unstable and collapse. Also sometime slopy subsea strata, seabed is very good, but the strata is inclined. This is what normally happens even in the case of conventional pile driving, everything seems to be perfect. When you are driving against a sloping surface, the pile goes and buckle at the edge, and then you will see that pile is going easy. In fact, one of the project what has happened is the pile was being driven exactly like this, there was a slopy stone at 60-70 meter below, and when it was trying to hit this surface the material is so strong that it is not allowing any penetration to go vertically. So, what has happened is the pile is trying to buckle against this inclined surface and going very easy. So, there was a resistance basically encountered by the pile driving, it could be noticed from number of blows required, but later it was going easy. So, the contractor was thinking something it has broken, thought that it has broken the hard material and going down, but without realizing the pile was buckling and there was a clump of material of piles assembled or accumulated together, and which is why it was going very easy, but it was not able to be noticed until such time the blow counts were going so small, in one blow it was going very fast. Then they decided to investigate, found that the pile already have collapsed because there was a big boulder just below so many meters into the ground. So, you can see this type of conditions could also potentially a problem to the jack-up, because this leg will go and get stuck, the other 2 legs may keep penetrating because the load is going there and try to collapse there. So, this process of installation and monitoring of all the legs and positions is vital to the safety of the jack-up. The other thing what may happen is basically a small rotation causing a large moment, basically because this is being non-redundant system, it could cause complete failure depending on the differential settlement of the legs. Even everything is perfect, we have seen just only 4 cases of possible scenarios, but even if they are all not there, a slight change in center of gravity, for example 3 legs are there, and if the COG of the system is eccentric to one side, increased loads, increased deformation of the leg can cause differential settlement. Now, we go backwards. So, you can see the design of superstructure facility for the jack-up, the COG of the system should be kept in mind, because you have to keep within the center area, so that you do not have too much of loads between 3 legs. Normally, when we design fixed structures, we do not worry about this, you can have as much load, as much penetration, as much foundation design, whereas this kind of mobile systems, you must make sure that when you are designing a jack-up, the COG of the system has to be kept as close possible to the center of gravity of the triangle, so that the loading between the 3 legs is not too much of a difference, to avoid this kind of rotational failure, which is very important. That means, when you are configuring the leg, when you are configuring the hull, the pontoon locations and the superstructure. For example, you come up with a superstructure the center of gravity is not exactly at the center of the triangle. So, what can we do? We can do a ballasting exactly opposite side, so that you can bring the center of gravity. So, you have a manipulation methodology just to make sure that COG is, but despite all this, still if you have differential basically the settlement of the legs, it could be very small, but can cause tremendous effect because of the length of the leg, and the moment created at the top can simply collapse. Several locations this has happened, basically the jackups collapsing against existing jacket. 1980s at least several of them collapsed against the existing well platform because of simple stability issues. Though the soil is good, verified, but unable to stabilize because this kind of disturbance can cause rotation of the structure. The other instability which we just now discussed is basically installation on a slopy underbed strata. Basically one of them is getting full bearing, the other one is not getting bearing. So, what will happen is trying to destabilize the system and then collapse against the jacket. This also is cause for worry. So, that is why when you design a jacket we do one borehole, but when we do a installation of a jackup we always look for more borehole, maybe 2 or maybe 3, so that you also look at the variation of the profile substrata below, so that whether it is safe to install or unsafe to locate there. So, basically that is the idea. If there is such a situation, what can we do? We have to pre-plan it. So, increase the weight here before it goes here. So, basically the penetration will become more uniform. So, you do a ballasting on that side, so that you control your. So, all these calculations needs to be made depending on the situation there. What are the failure modes? Basically is by this time I think you would have understood what type of failures are expected depending on type of soil, and mostly since jackup legs cannot penetrate through rocky bottom or sandy material. So, predominantly clay type of material is only used. So, only a matter is whether the clay is uniform or several layers of different strength. But typically what was expected out of a clay is basically a squeezing effect. Basically if you have a jackup spud can going down. So, you see in picture A, if it is good soil, very good clay, what is very good clay is basically your shear strength is higher. So, we will talk about in the next semester what is the type of number 5 kPa, 10 kPa, untrained shear. I think most of your civil engineers will be able to understand. So, if it is a good soil, when the spud can goes down, the lower bottom cone can just penetrate, but then you get a full bearing of the circular mat foundation. So, if substantially good soil, you may not even penetrate, it just getting enough bearing capacity. Or if it is a very soft clay like this, like very soft clay. Very soft clay means when you step into that kind of muddy area, your leg goes down. I think you might practice if you go into several places in the coastal zone. It is like less than 5 kPa kilonewton per square meter. That means 500 kg loading, it will just simply sink. So, that is the kind of soil we are talking about. Then when you have such scenario, the soil will just, the clay will try to squeeze and just bulge away on the circumference of the spud can. So, you could see here depending on the type of soil, the behavior is going to be different, but after all what happens as the leg moves substantially down, this soil is not going to stay like this, it is going to collapse and come on top of the spud itself. So, this behavior will depends on whether it is a single layer or multiple layers or very soft clay, medium. So, you will require a numerical model. Simplified calculations using foundation design may be not going to work for us. So, most of the time for this type of study we use a 3-dimensional finite element programs to simulate the behavior under varying strata conditions. That means more than a fixed structural system, here every time you are going to do this, basically every time when you are planning for a jackup to be mobilized to a particular site, the amount of work done is enormous. How do we evaluate the bearing capacity? Basically, since we are introducing this subject in the next semester, we may not want to go into full details of this particular aspect now, but I think most of you are civil engineers, I think. So, must have studied soil mechanics, basic soil mechanics in your course. Just will introduce this and spend maybe tomorrow 1 hour